Hello everyone, and welcome back to Revit Snippets, great tips you can learn in just a few minutes. For today's lesson, let's get together to build this very attractive canopy structure in Revit. It's a very famous project in Seville, Spain, called Metropol Parasol. I hope I'm saying that properly. This is a very good example of a waffle structure. So here how it looks like from the ground. Here's another shot there. That's the roof plan. You can see the whole roof structure is there and is supported by multiple columns that look very similar to tree trunks. So we have one here, one there, another one here, here, and there. Essentially, wherever you have a circle there, the center will be a tree. This is the render image from the architects themselves, and as you can see there, that's very similar to what I have built already in Revit. Of course, there's a lot more to this project, like the base there and the escalators. But for today's lesson, let's just focus on building this roof structure there in Revit as a 3D fully parametric canopy. If you follow this lesson to the end, you will get something like this. So fully in 3D, I can see that's a canopy there and all the tree trunks supporting it. The whole thing is essentially a system of two collections of structural framing, one going in this direction and the other one going in the perpendicular direction. Because I have built them all in Revit, you can quickly generate elevation sections and so on. That's the elevation there, everything fully parametric. By the way, if you are new to this channel, make sure to subscribe now, because we do tutorials like this every single week. Okay, let's get started. The first step is to select the right tool for our job. Doing this system here in Revit using Dynamo or just Revit itself may not be impossible, but it will be very tricky. This is because this project requires a combination of different surfaces. So if you can imagine, each column here can have its own surface. So we have 1, 2, 3, 4, 5, 6 of them for 6 columns. And for this roof structure to be successful, all 6 surfaces have to merge into this simplest, very organic form, which you can then slice using structural framing systems to create this overall massing. With Revit and Dynamo, as soon as you try to merge different surfaces, it's super hard to do. So that's why today we will use another new tool called Rhino Inside. That's what I have here under the Add-ins tab, and it's called Rhino. Let's click it now to launch it. By the way, it's not something that comes with Revit installation. It's a plugin you need to install separately. If you haven't done that already, go down to this video description and simply follow a link there to another tutorial I have done on how to exactly get it set up for your Revit. Alright, because I just launched that, now it has created for me an additional tab in Revit here called Rhinoceros. Let's start using it now. Firstly, I will close this project down and create a new one so we can start fresh. With this open, let's go to Rhinoceros and click on Rhino. This will launch this Rhino 7 as an application that is attached to your Revit session. It's a great application for modeling freeform geometry, something like what we try to do today. Let me just quickly dock it to the side and put Revit on the other side. Go to 3D here now. So whatever we want to preview in Revit will also show up. And I'm gonna go ahead and give Rhino a bit more space. Just like that. Now, the first step to successfully model a real project is to get a sense of scale. We need to know roughly how big the project or the structure should be. Because this is a real building, we can simply just go to Google Maps. That's what I'm opening here already. And if you haven't done it, just go here and search for Metropol Parasol. It will take you straight to this location of the building in real life. Here, my goal is to get the overall distance between the top point there and the lowest point here of the structure. That's super easy to do. We can now just right click anywhere and choose measure distance. We can now click on 2 points to place a line for measurement. So the first point is there for us already. We can now drag it to here. And now as you can see, the total distance along this line is just over 170 meters. Next step, you need to get an image of the roof plan for this project. I have done this for you already. So here's an image of the roof plan. I will include this in the download link in this video's description for you, so you can get it for practice. But for now, we need to link it directly into Rhino, so we have something to trace on. Let's start by drawing a rectangular surface to host the image here. I can go to here now and choose rectangular plane. The first point can be anywhere, and then we can specify the length of the plane itself. I know it's going to be 170,000, and then the width can be anything you like. I will just do it proportionally, maybe to here. We can now select this plane, go to materials, and now instead of using the layer material, I can click here now and choose to use a new one of the custom type. Under this materials properties, look for textures, color, and then tick this box. It will then prompt you to select an image. I have here already the folder with the photo inside, so I will just select it here and do open. Nothing shows yet because we need to change this view as well to rendered mode. And you can see now the rectangle is of the wrong direction. That's easy to fix, however. Instead of rotating the rectangle, I can just rotate the image under this materials properties. So here now, click on this image name, and underneath properties, we have this one for rotating it. Let's try 90 degrees. Now that's better. However, I can see the rectangle is a bit squashed. Let's now do scale 1D and get this to be the reference point. I can now scale it to make sure anything circular will appear circular. And finally, we can do rotate to bring this into position like that. Now that's something ready for us to trace on. Let's begin by drawing individual surfaces that our individual columns will support. So we have here 1, 2, 3, 4, 5, 6 of them. Actually, you know what? Before doing so, I will make sure that this distance from here to here is actually 170 meters. Let's draw a circle now to verify this. So, radius 170,000. Oh, it's not the same. So I need to scale this one more time. From this point to here. There we go. Much better now. We can now start drawing circles for individual surfaces. Let's go to circle again. And the first one will be here. It's black, so a bit hard to see. Let's now go to layer and change the color now to red. Here we go. I will do this 5 more times. Okay, there you have them, all 6 circles. We now need to connect them. So I can go to here and select arcs by 3 points. We now need to define the starting point of the arc. So maybe let's turn on nearest point snapping. And now snapping to our circles there. I can begin to connect them like this. And do this a few more times. Over here, where it doesn't make sense to use just an arc, we can also go for interpolated curve and draw it the same way. It just gives us more control points to work with, so the form can be exactly like we need it to be. Whenever possible, however, go for the arc, because fewer points means simpler form. Here we go, all connected nicely. I can now change the view back to shaded mode now. And now only focus on my curve. This plane is getting in the way, so let's make a new layer now for hidden elements. And put this plane there. And then turn off the layer. Here we go. Next step, we need to trim them to make them into one single closed boundary loop. So I will select them all like this and do trim. We can now select the portion of curves that we don't want to keep, so these should go. And now there's one single curve boundary there. Or is it? Even though they appear to be a single element, I can still select them individually. Let's now truly unify them into a single surface. I can now get them all like this and type in planar surface. This one here. And as you can see there in the command line, the operation wasn't successful because this curve loop is actually not closed. Let's see why. If I now select this first curve there and zoom way into the intersection, you will see there's an overlapping region where this curve will go into the other one here and this other one here go into the first curve. This won't allow us to make the planar surface successfully, so we need to sort this out. That's easy to do as well. I can now just select this curve, click on this endpoint and move it to where the other curve ends. This is where we need to turn on endpoint snapping. And see, that's the endpoint there. These two are now fine, perfectly connected. Let's do the same for the rest of curves here. You can see there, this one is okay. Looking good here as well. And here, that's the same problem. So, just like before, select endpoint, move it to where the other one ends. I will do this a few more times. Okay, let's try to make the surface again now. Select all, planar surface, and here it is. Next step, we need to convert this surface now into a mesh. By the way, I forgot to mention, there's a new command in Rhino 7, which I'm using here exactly for this purpose. If we go under the New in V7 tab, it's here called Quad Remesh. With the surface selected, I can now click on Quad Remesh. And here you have all the required options to turn this into a mesh. I can now choose Preview to see how it's going to look like. Here we go, so that's what I'm getting if I accept just the default settings there. This is however too detailed for our purpose. The plan for today is to convert this mesh into a subd object, and if you have previously used subd modeling in Rhino, you will know the simpler the mesh is, the easier it's going to be later on for us to manipulate it to get the form we need. So let's dial down a few numbers here. How about this one? That's much better. Can I go even lower now? Yeah, not bad. However, the best way to turn this surface into the mesh for our purpose today is to use a combination of this command and some guide curves, which is one of the parameters here we can specify. So I will cancel out this just for a moment. And now we can draw some guide curves that the quad remesh command would use when it tries to turn this into a collection of meshes. To do this, go to here and choose again interpolated curve. We can now draw some curves that outline the overall skeleton of the form. So starting from here now and ending here, that's one curve. Let me just put this one on this hidden elements workset so we can see those curves easier. The second curve will be like this, starting from here and going into this other trunk right there. The third one may be going this way. You can see I'm essentially just connecting the center points of our circles from the beginning. So one there, one here. That one, this curve goes through its center point, same as this one here. And for these two, the curves are ending exactly where the center points will be. Okay, I can now turn on back my surface. This one we can now actually delete. So with that selected, we can do quad remesh one more time. And this time do select curves. And this time just hold down the shift key to select them individually. When you are happy, right click and do preview. With this set to a lower value, I remember from before it was 100. Let's try that again. This time with the guide curves. Much better now. You see, because we have guide curves in place, the mesh actually tries to orient itself and its subsurfaces to follow this basic skeleton. Essentially, we want to get this for each of the circles. So we want to have a core row of mesh surfaces with another layer of other mesh surfaces going around that core row. It's good here, but over here and there I still have more detail that I would like to have. So let's try to dial this one a bit more down, maybe 75 or even 50. Yeah, that's going too low because here now I'm losing that core row for this circle. So I guess for now, let's go back up to maybe 60. And that's something I can work with. Let's do OK now to confirm. So we have now this. Let me select it now, the mesh, and put it on the default layer. This way, when I turn off hidden elements, I will only see this now. Those curves here, we don't need them anymore, so I will also put them on hidden elements. There we go. Now, so far you might be wondering, it looks nothing like the very organic freeform design that we're trying to recreate. But don't worry, this is all part of the plan. Because in Rhino 7 here, we can certainly make use of the new feature called subnew modeling. This is a group of commands that are now under this new tab, subnew tools. Essentially, this is the method of modeling where we define our form in a skeleton or ridge-like manner, as I have done with this mesh surface here. And then the subnew engine will automatically smoothen our mesh to create the freeform object for us. We are using this approach because it offers an easy way to merge different surfaces into a single form. So let's begin with subnew. With this mesh now selected, I can go up here and choose Convert to subnew. Accept all the defaults for now and click Enter. That has done it. If I now select this mesh now and hide it. This is the subnew element that we just created. I can now go to Perspective and check it out. Maybe in shaded mode. So, the mesh we saw before with all the very sharp edges has been smoothened by this new engine into this very organic shape. And it's not just a one-way operation. You can actually toggle and go back and forth between the mesh representation and the smooth appearance. To do that, just press the Tab key. So we have here the mesh, tap again. Now we have the smooth form. The color is a bit strong though. Let me just turn this one back to maybe blue. Yeah, that's easier to see. It's time now for us to begin sculpting this form to closely follow what we have in the reference project. To begin modifying the subnew object, you need to use a shortcut for sub-element selection. So here if I just click on the form, I'm selecting the whole object there. But let's say I want to select only this subsurface of the subnew. I need to hold down Ctrl Shift and then click on this surface there. Now it's highlighted, that means that's selected independently from its host element. To move it down or up, I can now turn on this gumball. And now just a matter of dragging it down using this blue arrow there. You can see it's very easy to have curvature integrated into our form now. If I now press Tab to see the mesh, you can see that mesh surface has been pushed down. And now when I press Tab again, that whole thing has been smoothened on the fly for me. Let's do the same now for the other 5 circular areas of this form. This one is a bit special. We have to select maybe 3 surfaces instead of 1. So Control Shift and then 1, 2, 3, and then drag all of them down. Here we go. That's a much more interesting form already. Anyway, it's lying flat on the ground. Let's go to the front view. And let's say we move this one up by maybe 15 meters. Oh, that's too high. I'll bring it down here. Okay. Go into the top view. Let's also center it, so the origin point of the drawing space is somewhere here, near the center of the form. That's just easier for Revit to handle later on when we bring this to there. Back to perspective now. I can now select the whole thing and do offset subnew, this command there. As you can tell from the arrows, it's gonna offset this form up. The distance, let's say we can try 300. And choose to create a solid from this operation, yes, and then press enter. The thing has happened, however, I can see the thickness is a bit too low. Let's undo this. Redo the offset subnew command, but this time how about 1.5 meters? Yeah, that's more like it. I can now put the original subnew object to the hidden elements layer, because now we have here the second object as a thickened version of that. I quite like the curvature on the top and bottom surfaces there, but the edges, I think we can do better with them. This is because if I look back to the reference project, the edges are really curved. They have a gentle fillet applied to all of them. So let's do the same here now. Again, using subnew sub-element selection, let's hold down Ctrl Shift, and this time instead of clicking on one of the surfaces there, we can click on this edge to select it. With that highlighted and Ctrl Shift still held down, I can now double click on the edge on the right of this edge. And that has selected the whole chain of lines for us. We can now go up here and choose to remove the grease. Here we go. Here's a good time to tell you the difference between a grease and a non-grease. Over here, if I now press tab, you can see the top edge and the lower edge are still there. They seem to be identical in this case. The difference is the top edge is not a grease, while the bottom edge is. If I now press tab to see the subnew, that's the reason why the top edge there has been filleted, but the bottom one is not. Let's now do the same for the bottom one. I want to have both of them filleted. So, just like before, Ctrl Shift, select one edge, and then Ctrl Shift, double click the next edge. The whole chain is now selected. I can now also remove grease from those. That's now looking really nice because I have curvature both from the top and at the bottom. It looks very much like a flying saucer now. Moving on, it's time to create these very attractive columns. And here that's where I can take a look at the bottom of my form. Maybe even move it a bit up there. And now I can select again with Ctrl Shift this bottom surface there in the center of this circular region. With that selected, I can extrude it down to create our column. This is where we need to pay close attention to the gumbo. As you can see here, if I just drag this one down with the arrow, it's moving down and it creates this very chunky bulk here. So let me undo this, select it again, and now instead of using this arrow, the whole thing, I should only click on this little dot on that arrow itself. So now when you see moving it down, the thing has been extruded instead of moved. It's clear to see if I turn back to the mesh representation. You can see there, it was extruded, not moved. We can now make sure this surface is on the ground plane. I can go to front view and just drop a point in here. Under standards, do point and place a point right here at 0, 0. Now, make sure this bottom face is still selected. I can now do set point and make sure only Z is selected here. Click OK, and now it's going to move what I selected to match the Z coordinates of a target object. In our case, this point here. Here we go. Back to the subnew. You can see, even though the mesh surface is on the ground, the subnew is somewhere ending up there before it can touch the ground. This is because this bottom face here is also smoothened or filleted. To stop this from happening, we need to remove its greases along its boundary. back to perspective now. I can do Ctrl Shift to select its edge and then double click the next one. Well, sometimes it doesn't let you select the whole chain, but this case is okay. We can just go around and select all of the 4 edges for this surface there. Here they are. I can now go to subnew tools and then add grease. Now they are there on the ground because there's no filleting anymore down there. That's more or less very similar to our column now. But if you look closely, the fillet amount here is a bit too much. The column in our reference project actually goes up for a longer distance before it starts to widen and merge with the roof. That's easy to fix. We can go back here now and select these 4 lines. Now, the trick is to copy them down so the column can maintain its upwards direction before it gets to filleting mode. To do this, simply go up here and choose Insert Edge. As you can see now, we have the same 4 edges being copied down. I can place them here now. And now when I switch back to subnew, that's a much more controlled level of smoothing. To make it even more natural, I can also get the top 4 lines and make them just a bit bigger than those 4 lines below them. We can use this scale button here with the shift key held down for that. Here we go, back to subnew. That's a much better transition right there. Okay, I will now do the same for the other 5 columns. That's the second one. Third one is done. For that one to go. With this one, because we are extruding 3 surfaces, the combined profile of them doesn't look like a circle anymore. That's also easy to fix. I can just Ctrl Shift on this edge here to select it and simply move it so this rectangle here will look more like part of a bigger circle. Maybe something like that. And do the same 2 more times. As you can see, we can also move this one away. And the same here. So essentially, now the 3 there, they kind of make up a hexagon, and when smoothed out, that will look more like a circle. These 3 now, they are redundant because I don't want to have different surfaces down here anymore. I want to have only one. So after selecting them like this, I can just press delete. And now they are gone. Let's now also add the grease to these edges there. And also adjust this one the same way we have done for the other 5 columns. Amazing! Now we have all the columns we need. It's time now to also adjust the form slightly. Actually, you know what? I missed one column here. So let's create it now the same way. Looking good. Okay, all 6 columns created. We can even check them out in rendered mode. Here we go. Really smooth surface there. Anyway, if we now look back at the reference project, these columns, they don't all come straight from the ground. If you look into this one, for example, it actually is slanting a bit, even wider at the bottom. And that's very visible here. You can see this column there is slanting to the left, that one slanting to the right, and so on. That's what I do just to make the form a bit more dynamic. No worries, we can do exactly the same thing. So back to Rhino. I can simply shift select this bottom face there and really just move it slightly this way. Once smoothened out, it will look like that. Now you see, this is why I enjoy using subnew. It's super easy to change the form once it's created. I can even bend this section a little. So let's say I select these surfaces there, Control Shift and then Windows Select. I can disable snapping for a moment and just rotate them slightly like that. Now when I look at it from the front view, that's slanting as a column and also slanting in the roof. Let's do the same now for the other columns to add a bit more interest into our form. Sometimes if you make this one slant too much, it may feel like there's no longer a smooth transition there, or at least not natural. Worry not, you can simply switch to the mesh appearance, get those lines, and move them slightly in the same direction. Now that's a lot more natural to me. Let's do the same 4 more times. And to finish this off, I can also get those surfaces there, disable snapping, and rotate them slightly. Yep, that's a very funky one right there. Maybe a bit too much. Let's select it again and rotate by a smaller amount. Yeah, that's okay. Alright, it's time now to use this form to create our structural framing for mimicking this waffle structure. By the way, you may have noticed that I didn't really build this second roof here to get the pavilion space inside. And the same one there, I'm skipping it, because once you know how to do subnew modeling, it's essentially the same principle to add a second subnew on top of this one, merge them together, and manipulate the form the same way we have done so far. So these two will be your homework. Or if you like me to cover them, simply say that in the comments and I can do maybe a part 2 of this tutorial to do this second roof. Okay, so far so good. We have got the form we need. Let's now bring this into Revit and create our framing. One way to do it is by using Grasshopper. So I can go back to Revit now. It's time now for us to be in Revit again and open Grasshopper. So this window you see here, that's a Grasshopper window hosted on top of this Rhino window. And this Rhino window is in turn hosted on top of your Revit application. So grandparents, parents, and children. Let's now make them work. Firstly, we need to bring this form here into Grasshopper as a subnew object. So let me just double click now and search for subnew. It's there as an empty node. I can now right click and choose to set one subnew. Click on this form there. And now the form has been internalized into this node there. Sometimes you can even see it in Revit. Let's see. Not yet, it's gonna come soon. Anyway, you can see in Rhino the form has been overridden with this color. That's a preview on top of the original shape. Let's move on. To create framing on the first direction, I can now do contours. The shape is obviously our subnew form there, so let's connect it to here. This node here is simply a slicer. It's going to slice this form repeatedly following a certain interval to create closed polycurves that represent this form. So let me show you right now. For the direction, that's the direction along which the cut should happen. So let's try simply for now x unit. That's the unit vector for the x-axis. I can plug it to here. And for this to run, we also have to specify the distance between two adjacent profiles that this node will produce. Let's start with something big, maybe from 1.5 meters all the way to 10 meters. Let's go with 10 to begin with and bring it to here. So you can see when I click on this, highlighted in green there are those contours or profiles that have been created by slicing this form along the x-axis. This is fully parametric. If I now change this one to something smaller, maybe 5 meters, you have more contours now. That's very nice. Let's now do the same for the second direction. I will copy this node there, Ctrl+C, Ctrl+V, and bring it down here. The only difference for this second node will be the direction. So instead of x vector, let's go for y unit vector. Connect to here now. And you will see now we have not one but two systems of contours. First one there, and second one here, perpendicular to it. To see them easier, let me just select everything here now, and hide them for a moment. Now we only see preview elements from Grasshopper. Let's also turn off the subnew. And here are our profiles. Let's now create surfaces from them. The node to use here is boundary surface. This one there. Now I guess you know what to do. We can connect contours to edges, and immediately I have surfaces coming back. Next step is to extrude those surfaces to create solid objects. There's a node for that, of course. It's called extrude. The base curve is certainly that one there. And for direction, we can use this same vector here. But we need to also amplify it, because as a unit vector, the length of the vector there, as you can see in the tooltip, is only 1 unit. In our case here, that's 1 millimeter, and that's too thin for any meaningful structural members. So let's put in here amplify, or amplitude to be exact. Connect the vector to here now. And for amplitude, this is where we specify the thickness of our frames. I will go for 100 in this case. And connect vector to here. Immediately you can now see we have here 3D objects 100 millimeters thick. Now I'm wondering if there's a preview in Revit already. We may have to reopen the view. Yes, here they are. From this point onwards, we can just work with Revit and Grasshopper. Rhino is still there in the background, because that's where the subnew form is coming from. But in terms of creating structural members, we only need these two windows for now. So, to bring these frames into Revit, let me actually close Rhino so it won't get in the way. Okay, so to convert those objects into Revit elements, the simplest way is this. Go up here to the Revit tab. By the way, you won't see this tab if you run Rhino 7 on its own. This only appears when you run Rhino Inside Revit. The node to use now is under this group for direct shapes, and it's called Add Geometry Direct Shape. The category is obviously something we can select, so let's go back here now and choose Direct Shape Categories. When you click this, you will see the same familiar list of Revit categories. For our purpose here, let's select Structural Framing and connect it to there. The material we need to specify by name. Let's go to Material here and choose Query Materials. In here it needs a name as an input, so let's go ahead and create our first material. Under Settings, choose Materials, and I'm gonna just start from the default one, make a duplicate of it, and call this one Timber. Go to Appearance now, duplicate the appearance, and let's choose something like a brown color for this one here. Use the same now for Render Appearance Shading Color, and be good to go. Before we leave this window, I will right click here and copy this name. And now in here we need to specify the name. Let's double click now, do quotation mark and then Timber. Once I press enter, that becomes a panel as a text input I can use right there. You can see there, it says one material has been collected. I can then pass that straight into here. And finally, I can connect the extrusions to the geometry input. Depending on the speed of your machine, this may take a few minutes to run, but on my system here, it should be more than a few seconds. Alright, if I now check in Revit, that's one structural framing object. You can see there in this tooltip, and that's exactly what we need right now. Let's now do the same for the second direction. To do this quickly, I can just copy these 4 nodes there, Ctrl C, Ctrl V, bring them down to this space, along with this contour node. When I do this, I also don't want Revit to continue recomputing the result, so I can now middle mouse click and choose to pause or disable the solver. Now we can go and connect contours to edges. And for this vector here, we should use the X vector. It should be this one here, Y unit vector. When I think it's ready, I can now middle mouse click again and re-enable my solver. This will let the script continue to compute and get me those additional structural frames. Here we go. I can see them in Revit already. Looking nice. But the spacing is a bit too big, and that was on purpose, so we can test the script quicker. With everything now in place, I can simply change this value to make it exactly like what I would like to see in the final structural framing system. It may take a long time to process with a smaller interval, so as always, use a good habit of saving files before this final step. And then you can go here, change this to maybe 1.5 meters and press enter. Now it's gonna run. Okay, that has finished, and now we have something nice to look at. Let me just turn off the preview from Grasshopper so we can see the real thing in Revit now. Let's go up here and close the script. Do I want to save it? Yes, please. And now we only have those elements in Revit. Let's see how they look like in a better setup light. That's quite nice if you ask me. Simply set up a few views and you will finally get to something we saw at the beginning of this tutorial. Something like that. If you enjoyed this lesson and want more like this coming every single week, make sure to subscribe to this channel. I will soon release even more tutorials on Revit with or without Rhino Inside to create exciting structure just like this. Also, if you're running out of time and just want to download right away the Revit, Rhino and Grasshopper files, simply go down to the video description and use the link there to get all 3 of them. For now, practice what you've learned, and I'll see you in the next lesson.